Welcome to the afternoon session. If you can make your way towards the middle of each row so people who are coming in can get a bit of space, so move in if you can, that would be great, thank you. And I'd like to introduce you, Paul, that's right, sorry. And he's gonna talk about historical aerial project. So join me in welcoming Paul to the stage.
Thank you, and thank you all for coming to my humble little talk, as opposed to all the other wonderful talks happening right now, also delivered by white men. If you are not a white man, please submit talks for LCA next year, that'd be great. Thank you. When I put these title cards on, just play some honky-tonky silent movie piano movie in your head. I did try doing that for real, but it got annoying real quick. But if that helps, please imagine that. The last two linux.conf LCAs, actually, I've presented on my ongoing work on open source tools for processing and publishing Earth observation satellite imagery. I gave a lightning talk in Sydney and a full-length talk last year in New Zealand. That work is ongoing. This is about something else though. This is about a new project, tangentially related, although it's still with Geoscience Australia, a different team within GA. It's funded through PFOD, which is the Platforms for Open Data program, which is part of the National Innovation and Science Agenda. PFOD is a program that lets Australian government departments propose small projects based around open data, either opening up new data sets or making existing data sets more accessible. And if those proposals are successful, they get funding to work on that project with Data 61. They're usually fairly small self-contained projects or pilots for larger projects. They usually run sort of 12 to 18 months with a fairly small team. So Earth observation satellite imagery is great, and we love it for recent imagery. But before Earth observation satellites, there were these quaint vehicles called aeroplanes, and before digital photography, there was film. Geoscience Australia has inherited from its various predecessor organisations an extensive archive of historical aerial photography. There's around just over 1 million images. It stretches right back to the 1920s and continues well into the satellite era, up until the sort of mid-90s when aerial photography started to switch over to digital photography. There's full coverage of Australia and beyond. There's also a lot of imagery of various Pacific islands that were once administered by Australia, places like Western Samoa, Tonga, Papua New Guinea and so on. The temporal coverage varies. More remote parts of the country might only have been passed once or twice. Areas of economic interest, so capital cities, but also areas of mining interest and areas with potential pastoral exploitation have been photographed much more frequently. Overall, it's an absolute goldmine of historic mapping imagery. This is the second PFOD project that I've worked on based on an historical data archive. The first one was on historical electoral data for the Australian Electoral Commission. This seems like a good opportunity to make a few general observations about features common to historical archival data projects, because they're really different from the sort of projects that we normally get to work on. With these historical projects, the canonical source of truth is ultimately pieces of paper, often handwritten. The handwriting is usually fairly neat, but styles of handwriting have changed a lot over the last 100 years, and some of those early handwriting can be very difficult for modern eyes to decipher unless you are used to reading handwriting of that age. There's often been multiple attempts at scanning and transcription over the decades. In theory, that should make our life easier. In practice, some of that scanning and transcription was not really done in a very well-informed way. There's often It's easy for data to be duplicated. It's easy, and also errors can be compounded over time. So it's actually fairly important to go back to the original pieces of paper whenever possible. And ultimately, the accuracy of the original data is maybe not always up to the standards that we would expect today. I think for these projects to really work, there has to be a historian, a person in this historian role, whose job it is to sift through and collate this paper-based information and collate it into a machine-readable form. Ideally, that would be at one person. That obviously makes the project take a lot longer, but the consistency and also just the experience, the accumulated experience that person will develop means that you get much better quality data out the end. We typically use, when I say machine-readable form, that invariably means spreadsheets, partly because spreadsheets present a low barrier to entry, and particularly if your historian is actually an historian, they might not be as technically literate as most of the people in this room would be. But also, the data model typically evolves radically over time. Assumptions that you make going in that seem perfectly reasonable and seem to hold for the first 3 or 4 months of the project, suddenly you'll come across a new chunk of data that completely throws that out the window. And you have to really completely rethink the way you're structuring your data. So spreadsheets are amenable to being sort of rapidly adjusting to those sorts of changes in a way that a more sort of formal data entry system can sometimes sort of put up barriers against. So yeah, your implementation has to be. So for this particular project, for the historical aerial photography, I'll just point out that the spreadsheet, the main spreadsheet we're working with is currently sitting at about 50,000 rows. Excel has a limit of 65,535 rows, so we're getting pretty close. Yeah, you can't be too picky about data integrity because you can't impose integrity after the fact. You just have to work with what you've got. So yeah, what have we got? We've got lots and lots of these. They're quite beautiful. We call them flight line diagrams. Other jurisdictions have slightly different names for them, but they're basically the metadata for the imagery. So as you can see, there's a map. There's a series of lines, which is the path that the plane nominally took. Those lines are labelled with run numbers, and also the number underneath is a film number, so that's the number of the actual film that was being shot. Those small dots along the way are the frame numbers within that film, so you can follow there. They start on the right at the top, go over the left, then there's a 5129, they've turned around to 5133 and come back, and there's this zigzagging back and forth. Those intervening frame numbers, there usually is actually imagery on the film for those, but the plane's usually banking, or so they're not quite so useful for as data, but they are there, and we will be scanning those. This is a fairly neat flight line diagram. It's pretty clear and legible. It's from the early 60s, and I think that lettering is all probably Letraset or some sort of similar technology. The earlier ones are often handwritten, and even if they're not handwritten, if they've been typed on, often there's quite a lot of hand annotated information around the edges of the spread of the diagram. You can see here they've got the 60% overlap only. That's a typed strip of paper that's been glued on. That's really typical. There's often little inserts and things that have been glued onto the imagery. A lot of these images, a lot of these flight line diagrams were scanned in the early 90s, but those were fairly low resolution black and white scans, and there's a lot of lost information. When we dig the originals back out, we find that there's a lot more legible info that we can pull out from them. Sometimes those scans are so bad that it can take us quite a long time to realise that two images are actually the same diagram. And we keep finding new ones as well. As Douglas Adams would put it, at the bottom of filing cabinets and disused lavatories with signs on the door saying, "Beware of the leopard." The archives at Geoscience Australia aren't quite that bad, but they get close at times. So the flight line diagrams give us the metadata. The actual data, of course, is the imagery, which is not on pieces of paper, but strips of celluloid. And all this flight line diagram metadata has to be considered provisional until we do scan the film. These were not created with GPS. They're only, they're fairly rough, and they're certainly not good enough to georeference the actual imagery. But you can't build software with paper and celluloid. So this is our sort of pathway from these pieces of paper and celluloid to useful data. The flight line diagram is that short flowchart on the right. We start with the archival flight line diagrams. We do high resolution scans, and then we georeference them. So we georeference that map, we georeference those flight lines, we georeference those image points that we have, and then we interpolate the intervening points as well. So I've at least got a rough idea of where those images were taken. That's pretty well. That's the flight line diagram digitization and georeferencing is pretty well advanced. We're sort of 90% complete. We're just sort of going back over the last few tricky ones to clean them up and get them done. The film digitization process is a lot more complicated, and it's also a lot less advanced. We start with the archival film stock, which is kept in cold storage in archive buildings. We take that out of cold storage, slowly raise it up to room temperature over a course of a day, scan them in a high resolution transparency scanner, then very carefully, because old film stock is brittle, and then carefully, slowly cool it back down to storage temperatures and put it back in the fridge. Then we georeference the images, then we georectify the images. Georeferencing and georectification are both fairly manual processes. There's some sort of automation you can do, particularly from like one frame to the next, but it is a fairly slow and manual process. But once we have those georectified images, it's fairly easy to automatically produce useful things like stitched mosaics and 3D elevation models. Because as you saw from that last flight line diagram, there's quite a large overlap between the images, about 60 to 70% overlap between adjacent images. So you can get quite decent parallax, and you can build up quite good 3D models. This, in fact, is exactly how they used to make topographic maps. They would get two adjacent films and look at them through a little stereoscope, and that's how they worked out where to draw the contour lines on our on topographic maps. The stitched mosaics are of interest to me, particularly because once we get into that format, we can deal with them with the exact same software that we use for dealing with the Earth observation satellite imagery that I spoke about earlier. But yeah, so those stitched mosaics and elevation models are sort of the real goal. Film digitalisation, as I said, is far less advanced. People who really want an image can ask to get it scanned, and then we'll sort of scan the whole film, and that goes into the digitised archive. But yeah, we charge for that. It's quite expensive, and it's even quite difficult to actually find out what's available at the moment. There was some funding for scanning a few years back, and about 20% of the archive is scanned, but there's still a lot more to go. We're really hoping that this project will help raise awareness of the archive and help attract further funding to complete that scanning process, because it is getting urgent. Film stock doesn't last forever, and these high-resolution transparency scanners are starting to disappear from the market as well. It's getting harder and harder to do, so we really need to get a move on if we're going to do things with this. World domination. The various Australian states have similar smaller archives, as indeed do other countries. I spoke about this at a conference in New Zealand late last year, and I met with the agency in New Zealand that managed their aerial photography archive, and they're facing very similar issues as we are, so we're hoping to do a bit of work together with them. Many of those jurisdictions, though, are significantly more digitally mature than Geoscience Australia, particularly just in terms of their scanning. Most of them, these smaller archives tend to be mostly or fully scanned. They tend to not be quite so advanced in the way they're thinking about the georectification and georeferencing and what they're going to do with this data longer term. And they do tend to be locked into proprietary software platforms. We're really hoping that other jurisdictions will start to show interest in this project. As I said, New Zealand already have. The Australian states a little bit more independently minded, with a bit of a not invented here attitude to these things, but hopefully we'll get them on board. Because what would be really great would be to the ability to do cross-archive federated search, to be able to do one search and search all the archives and find all the imagery pull them together. So how are we building this? Open data, open standards, open source. That's why I'm here talking about it today. All this scanned imagery will be made available under Creative Commons by attribution style licenses, both the flight line diagrams and the imagery. The search API that I'm writing is a RESTful GeoJSON style API, heavily influenced by STAC, which is the Spatiotemporal Asset Catalogue, which is an emerging standard for searching for spatiotemporal assets. STAC is in turn heavily influencing what used to be called WFS version 3, so the Web Feature Service version 3, but is now being called the OGC API. So that is two emerging standards that we can't follow exactly because they're not locked down yet, but we certainly have a very compatible conceptual model, so it should be fairly easy to map them across. Open source, Apache 2 license. It's all built on a PostGIS database, so we get lovely fast geospatial queries from that. It's written in Python 3 using the Django REST framework. I don't necessarily think that that's the absolute best way to do this, but it's something I know very well, and it's also something that I find that's very easy to do this rapid kind of agile development where the data model is evolving rapidly. Django's object relational model makes that really easy to deal with. It's API only at the moment. The devs at GA will be writing a UI for it later in the year. It's sort of an alpha proof of concept kind of stage at the moment. But we pull in the data from these various spreadsheets and geodatabases via various Django managed .py scripts. And then we have the actual application that publishes the search results. And those search results reference the S3 bucket where the actual scanned images are stored. Source code is on Bitbucket if you care. We'll eventually be moving to GitHub. The database is a star schema pattern, which is a DMOL normalized schema pattern, sort of came out in the mid-90s, I guess, with the data warehouse craze. It is really well optimized for search. When I first started this project, the project team had a much more kind of traditional, fully normalized database schema in mind. I was able to convince them that the data that they had just didn't have the integrity to justify that, and that what we were really doing here was search, and we should be optimizing for that. And I'm very grateful that we did, because we are getting much faster results than we would have if we'd tried to do anything else. The data model and the Lotus scripts are still fairly GA-centric, so they're really designed for these particular data spreadsheet formats and things that GA have been using. There's a lot of metadata elements that are very specific to the way GA's archive works. At the same time, there's a lot of stuff there that would be pretty common to any historical aerial photography archive. As we get, or if and when we get other jurisdictions on board, we'll really be able to validate that which elements of the metadata are common and which are just specific to us. What have we got so far? We have spatiotemporal search, which exactly follows the way spatiotemporal search works in STAC. And we have searched by a bunch of other interesting metadata fields, which I've listed up there. What's interesting, camera orientation, so that's either, most of this imagery is vertical, so shooting straight down. Some of it is what we call oblique, which is basically shooting out the window. Film spectrum, the early stuff is all black and white. As you go sort of forward in time, you tend to get a lot more infrared, black and white imagery, and then when you get into the more modern stuff, does have a colour imagery and colour infrared. Yeah, I won't talk about the rest of that, it's just boring. We can search for either flight runs, which are multi-line geometry, so that's those actual plane paths we saw, or we can search for the images themselves, which we either model as a point, which is the centroid of the image, or as a polygon, which is the footprint of the full image. The output is paginated JSON. I've got the option, you can either have sort of a JSON response with the geospatial elements embedded within that JSON as GeoJSON, or we can do the other way around, have the whole thing as GeoJSON with the metadata embedded as properties within the GeoJSON. It's mostly paginated. I do have unpaginated options for at the moment for debugging basically, but an unpaginated searches are a lot slower because they're pulling back a lot more data. So we'll probably turn them off at some point when we have clients that actually speak the pagination protocol well. What's coming next? As I said, we've got to continue this scanning and georeferencing process, which we don't really have the money for at the moment. We certainly, that obviously needs to be done. We need data entry and management tools. It would be great to eliminate those spreadsheets and let them be able to have our database actually being the canonical source of truth, so that we would need to give them the tools they need to maintain that going forward. Data model refinement, particularly with reference to other jurisdictions and other archives, and federated search coming out of that as well. We introduced some integration with Terrier.js, which is the free software behind National Map, which is the sort of the standard way of publishing geospatial open data for the federal government, and full stack / OGC API / WFS3 compliance is also desirable once those standards have actually been finalised. That's a lie, there's heaps of time for a demo. So I will just get that up now by first mirroring, because it's going to be impossible to do on a split screen. So let's maximise that. So, I mean, this is the actual API. So this is like an index page with the documentation for how the API currently works. We have a health status method, which is always a good and any useful thing to have in any API. As you can see, we search by flight runs, we search by images. We have referenced, for searchable fields that have a reasonably finite number of possibilities, we have reference points, so we can, you can use, the UI can use that for populating drop-down list boxes, for example. So the list of clients, which is the list of people who actually flew the missions. People like the ACT Land Office, the Australian Army, Water Resources Commission, Western Australian Government, and so on. Then we have our various search parameters. So as I said, the geospatial search by bounding box and by time range works exactly as per stack. And then the various other fields that I didn't talk about before because I couldn't be bothered, but film number, barcode. That's the actual barcode on the film canister. So I don't know how specific that is. Do other people have barcodes on their film canisters? They probably do. We can search by whether or not the images are digitised. We can search by geographic area, by name. Most of this imagery is indexed by the National Library of Australia, so you can search by the NLA IDs and so on. I'm going to do some examples. So I'm going to do that one, but I'm going to change it because I know that if I just search by cab, I get 549 pages or 5,000 results. So if I change that to 1.9, I get a few less, and I also get some interesting ones that I'll show you. So yeah, flight runs there. But you can see the general structure there. There's the dates. Some of the, particularly the older imagery, we don't often have very accurate dates. We know what month they were flown. We know, sometimes we sort of barely know the year that it was flown. That's why there's a from and to date to get those ranges. Information about the project, who flew it, who paid for it. These are the standard map sheet numbers. And then the geographical areas. So there's a few geographic fields. In this case, they're both the same. They're not always the same. When you do a geographical area search, it does search for both. Information about the camera, information about the film, information about the geometry of the mission, how high the aeroplane was flying, the overlap, and so on. And because I've deliberately picked this one, I know that we have one that actually has some scanned imagery. So if I can click on that image URL, and it's going to open with GIMP because it's a TIFF. But I'll do that. And there's our flight line diagram scanned and ready to go. And that's 18%, so it's quite high resolution scans that we've done. There's the actual geometry of the flight line and so on. Coordinates are currently in EPSG 3577. So this is the GDA 94. It's the standard Australian geodatum. I will be changing that to something a bit more standard, a bit more web standard, so WS84 or whatever later on. And again, if I do that same search but with images, I will get, here we go, so we've got thumbnail URL. So this is the low, this is already pretty big. That's a big thumbnail. And if I will press on the full size image, but it's going to take a little while to download. Even on our fast internet, they are really big images.
What resolution do you scan?
I don't know. I can't give you those numbers, unfortunately. I just asked what resolution we're scanning at. So while that's coming in, or is it? No, here it is. It's just arrived. So yeah, that's the full resolution. That's at 4%. So let's just zoom right into 100%. That is a big image and really very detailed. So I'm going to just go, that's the wrong one. So this is an unpaginated one. The reason I have this is because I can paste that straight into Terrier. So ab data, my data, web data. I'm going to set that to GeoJSON, otherwise it'll try and hit it with weird queries. And if I just paste that URL straight in and add, it will download that and it will draw it directly on the map for me. And there we go, there's our flight lines. These are all the flight lines from a CAB19 film. I can click on one of them and it will give me all that JSON data in the map. And this is really just Terrier.js out of the box when we actually teach it to use the API more natively. We'll be able to do some much cooler things. And I will show you now also some mosaics, some zip mosaics that we prepared earlier. So this is not aerial imagery. This is satellite imagery that we're looking at there. That's Landsat 8 imagery from 2018. But this black and white bit on the left is aerial photography imagery from 1966. And you can see that's way higher resolution than the satellite imagery. And really very crisp and detailed. If I move over here, we should find Mount Isa somewhere. Here it is. It's right at the edge of the mosaic. But you can see that even though the resolution's quite So I can see the individual buildings quite clearly on the satellite one, on the aerial photography one. Landsat just shows us a blur, but we can see that, oops, we can, that happened. Anyway, I'll move on to the next one then. And this is, again, satellite imagery. This is Sentinel-2 now, so it's slightly higher resolution, it's about 10 megapixels. So this is Swan Hill on the Victoria-New South Wales border. It's the Murray River snaking down there. So it is 2019 for the satellite imagery and 1964 for the aerial photography. Again, I can zoom right in there and I can really see every building. I can see trees in backyards compared to the satellite imagery. So it's really, really lush imagery there. I will briefly now just jump back to here and wrap up. There's insufficient funding to do this project justice, to really give this archive the treatment it deserves. Everyone on the team is having to juggle their time against other high priority projects, but we're all committed to this project. We're all quite passionate about it. We want to see this archive opened up and made available to the Australian people to whom it ultimately belongs. Yeah, it is an incredible treasure trove of data, and it would be a real shame to let it just rot. Yeah, that's all. Thank you. I believe we have plenty of time for questions.
I've got a couple of questions. One of them is, do you think, moving forward, that the reliance on satellite imagery is going to wane and move back to aerial photography due to the detail that you can catch?
Due to the what, sorry?
With the detail of the aerial photography versus satellite imagery.
Well, so I mean, the satellite images I was showing you are the ones from the open data satellites. So the Sentinel-2 from ESA and Landsat from NASA. There are private satellites that have much higher resolutions. Still, probably not quite as good as some of those aerial imageries. Aerial imagery is still being taken. It is now digital photography rather than film, so it doesn't come under the aegis of this project. But I mean, the aerial imagery will never replace satellite imagery, because the satellite imagery, we're getting complete coverage of the country every 16 days or whatever it is at this quite detailed resolution. Whereas the aerial photography is always going to be much sparser than that, because you do actually have to put a plane in the air, and it's not giving this continuous coverage.
And the second question is with regards to your final comment of lack of funding, resource constraints on manpower, etc. Are there intentions to open up to effectively crowdsource, if you will, and have others participate and assist?
So I think certainly for things like the georeferencing, I think there's room for that. We can't really let random people into the archives and play with this film, because it is so delicate, and it is a a finicky process. But I know New Zealand do that. They publish images saying, "Where's this?" And please, we don't know. And people are remarkably good at finding it, yeah, for sure.
Anyone else? Raise your hand.
Oh, thank you for the great talk. I have some ongoing projects in which the imagery would be really useful. I'm wondering, based on your experience, I suppose they are quite detailed, because since they are quite high resolution. Mm-hmm. My question is, do you think you could, and it depends on the areas they're scanned, do you think you'd be able to tell where streets are and buildings based on those maps, and have kind of like a decade
Yeah, well, I
thing.
mean, as you could see in those images that I showed you, that you can definitely see individual buildings quite clearly, and street lines, absolutely. And that sort of thing is really, I guess, the most compelling use case for it. Looking at land use over time and so forth. Yeah, definitely.
Thanks for the talk, Paul. I was just interested, what type of cameras were they using back in the day? Because like they seem like very high resolution. Like you can't see the film grain when it's scanned at so high resolution.
Yeah,
they
so
like
they're large format cameras. The actual negatives are this sort of size often. I can show you some of the camera specs, but they don't mean a lot to me. So. A couple more there.
You said earlier something about things that the public can get, but it's quite expensive. Are we going to be able to see this and search it for ourselves for free?
We're going to get see this imagery.
Yeah.
This imagery will be, certainly everything that is scanned now and everything that's scanned in future will be made available under a Creative Commons license. Absolutely.
So we can access it for free?
Yes, that is the intention.
Excellent.
That is the intention.
Thank you.
At the moment, if it's not scanned, then you kind of have to pay us to do this, to scan stuff. But once we've scanned it, that's available to everybody. It's not just given to you.
So I'm sure you're familiar with Nearmap, a proprietary service that's around now for this sort of data, including historical data from the time Nearmap got going. Is there any potential for your stuff to integrate with theirs, to take their stuff further back, even a corporate sponsor to help you with your work?
We could talk to them about that, I guess, but I think we would probably largely be seen as a competitor. And we kind of see ourselves as a competitor too. We're trying to break those vendor lock-ins that the existing archives have. We're trying to create an open source alternative. I mean, there are a number of platforms that these people are using, and to my knowledge, none of them talk to each other. So I don't see why we would be an exception.
Most of the imagery is black and white, panchromatic, or when does color kick in? Or
most of it is panchromatic black and white or infrared black and white. There's quite a significant portion of the archive is infrared. The colour stuff is sort of kicks in around, I guess, the 1970s-ish or 1980s even. And certainly those last sort of couple of decades are mostly either colour infrared or colour visible spectrum. The vast majority of the archive is black and white for sure.
Hi, how long do you think it will be before you can get away from spreadsheets for this particular project?
So that's a matter of getting the time to actually to write some data maintenance tools. That is something I'm probably working on this year, but when we'll actually get to that point, not for at least another 12 months, I wouldn't think. Just because I'll probably write some API methods this year to let them write to the database, but then the GA devs will write the UI. That's kind of the deal, the labour split. So I don't know how long they'll take. I can't answer that.
Any more questions?
One more thing I will say is that if any of you are mid to senior level Python devs, are based in any of the East Coast capitals, but preferably Canberra, who would be interested in working on interesting projects like this, mostly around open source and open data, please talk to me.
Okay, thank you, Paul.